I'm going to talk about the thread pool pattern and how to use it in Python. So the thread pool pattern comes up when you've got multi-threaded code. And when you're using threaded in this sort of normal way, you'd create a thread, you'd assign some task to it, like a method to execute. It would execute that method, and then when it's done, you'd join the thread. The only issue is that creating threads and then, destroying them, that takes time. It's a performance cost to that. With a thread pool, what we do is we create a set of threads that are going to be in the pool. And then when we have some queue of tasks, we can then assign them to the thread pool. And we basically submit them to the thread pool. And then the next available thread in the thread pool will run that task. And then we can then essentially do a join. We can wait for the result of the task. And when we do this, the advantage is that we're not having to create and destroy threads every time, which is going to involve that performance hit. With a thread pool, we're just sort of using the same threads all the time. So in Python, we can use a thread pool pattern by importing the right library. So I'm just going to import some libraries we need here. I'm just going to say import threading, and I'll say I want to time the execution of this. So I'm going to say from time import sleep import time it, and then I'm going to say from concurrent.futures import thread pool executor. And that's what we're going to use to make our thread pool. And I'll save this as desktop thread.py, or maybe I'll call it pool.py. And I'll run it, and I'll just say Python 3 pool.py. It's not going to do anything yet. Okay. So what we'll do is we'll have some kind of job for our threads to execute, and it'll just be kind of a naive job that just sort of sleeps the thread for 1 second, just so we can simulate something happening. So we'll just sleep the thread for 1 second. And then I'm going to have an execute method, and this is where I'm going to put my thread pool code, and I'll run the execute method. And I want to be able to just time the execution of it. That's why I imported this time it module there. So I'm actually going to say down here, test is equal to timeIt execute is the name of the method to call. I want to call it once. And this method here, I'll just run this method here, and it'll time the execution of it. And then I can just print out like the result time. So like test results, colon, and just output the number of seconds that it was running for. Okay, and here's where I'm going to put my thread pool code. And what I'm going to do is I'm going to create a thread pool, and I'm going to have it execute this method. And then I'm going to just, see the time here that it took to execute the method. So I can just say, executor is equal to thread pool executor. And here you give the number of workers in your thread pool. In other words, the maximum number of threads for your thread pool. And then to actually run a thread, you say executor.submit, and you give the name of the method to execute there. So I'm just going to say do job. Now you want to ultimately keep track of the thread that's being executed, and this function returns this futures object or future object, and you can save that. So you can say future is equal to, and then this object has a method. It has two methods. It has one method called, well, it's a few methods, but one of the methods is called .done. That'll tell you true, false, whether the thread is done yet or not. And it also has a method called .result, or result, I should say, that will actually wait until the thread has finished executing. So you can kind of use that in a similar way that you use join when you're using normal Python threads. So I can just say like, future.result, and we should expect it to hang for a second before it completes execution. So I'll say Python 3 pool.py. Okay, and it basically waited for 1 second, and then it finished the job, and that's why we got the test result being 1 second. If I put like another job here right after this, it'll be 2 seconds, because I'll do one and then the other. So it did one, waited for it to finish, does another thread, waits for it to finish. I could do two jobs at once with a thread pool pattern. I could say like this. I could say future 1, future 2, submit 2 jobs to do, and then wait for the result. If I do this now, though, and I've got max worker set to 1, my thread pool has a maximum of 1 threads. So what's going to happen is this first job is going to be submitted, and it will start working on it. But when this next job is submitted, it's not going to start executing right away because there's no available threads in the pool. It's going to have to wait until this thread actually finishes here before it can actually start working on this other job here. So this will actually, it should still take 2 seconds. And it does take 2 seconds because there's only 1 thread available. Each one of these things sleeps for 1 second. If I increase this to 2, though, we actually should be okay. So if I increase that to 2, now it should actually run both because it's going to say submit the job. Okay, I've got a thread to do it because I've got 2 threads. It'll do it. Submit the job here, and it'll do it because it's got another thread to do it, and we should be okay. Let's run this here. And we're back down to 1 second because they're basically running in parallel at this point, or running concurrently, I should say. So that's the basics of using the thread pool executor in Python. If you want to read up on the library a bit more, you can check out the official documentation. The one thing that you might want to look at is we didn't have any parameters with our method there, so we said here we said dot submit do job, and do job, this method here has no arguments here. There's no parameters here, and there's no argument that we're giving here. If you check out the official documentation, they will show an example here where they've got this function here, load URL, and they're passing it URL and timeout values here. So this just kind of shows you how to do it if you've got parameters. But really, that's the basics of using the thread pool pattern. And in the right situations, it can be used to improve performance because you're not having to create threads and then tear them down and recreate them all the time. You can kind of just maintain this thread pool and then just use it as need be. All right, thank you.